Hello, hi, I'm Punita here from Huawei Global Training Center, and today we're going to discuss about the content eNodeB device data part 4. So let's talk about basic concept of clock synchronization. So clock synchronization means that the frequencies or phases of clock signals maintain a precise relationship. So we have divided this into two types of synchronization method. So one is the frequency synchronization. Two signals have the same number of pulses in the same interval. The sequence start time and end time of each pulse can be different for the two signals. So this one most suitable for your FTD base station. Second is time synchronization, or well known as phase synchronization. Two signals have the same frequency, phase and pulse sequence. So this is most suitable for TDD base station. Let's look into the synchronization requirements of LTE base stations. In wireless application, the clocks of different base stations must be synchronized to certain precision. Otherwise, the service drop may occur when the UEs are handed over between the base stations. Base stations in FTD mode must achieve frequency synchronization, and base stations in TDD mode must achieve time synchronization. So let's look into the table. LTE-TDD, it has its own precision requirement and phase synchronization about 3 microsecond. But for FTD, the precision is same as TDD, but there is no phase synchronization required. So some FTD features requires time synchronization like EICIC for interference issues. Let's look into the type of external clock that can be configured or it is used in a base station. One of it is GNSS, or well known as a GPS clock system. So for the GPS clock system, this is the best clock mode and it has the most precise time sequence here. So we have the configuration here. So let's say the operator is using a GPS clock system, then they have to configure this command. And there is some tips over here. For the cable length, it has to be configured based on the actual length. If let's say it's 20 meter greater, then it will be affecting the clock precision time. And for the priority, the value 1 indicates that the current reference clock source has the highest priority, and the value 4 indicates the current reference clock has the lowest priority. So let's look into our lab whether we have a GPS clock system or not. So I'm going to just display the command to see whether is there any command related. GNSS is not available because some of the software version requires GNSS. So if no GNSS, we can still check for GPS. So for this particular site, we don't have any GPS clock configured. So the next type of external clock will be IP clock server. So if you're using an IP clock server, you have to configure an IP clock link. So before adding the IP clock link, you have to add the device IP with a logical IP towards the IP clock link so that the client IP and the service IP will be configured. Slot is always number 7 referred to the UMPT card. So let's look into the lab whether we have IP clock server or not. So I'm going to just list IP clock link. So for this particular base station, we don't have. Let's look into the other one. So both the base station doesn't have an IP clock link. So next, we're going to look into the synchronous Ethernet clock. This is another type of external clock system. So for this, we have to configure based on the port number. So the port number, which is range 0 to 1, will be the main control and transmission board, and the slot number indicates the extended transmission board. So the port value will be 0 to 5. So let's look into our lab whether we have any synchronous Ethernet clock of type of clock system or not. Okay, there is no any external clock system related to synchronous Ethernet clock. So next, after we have decided our clock system, now we need to set the system clock. So set the working mode of the reference clock. So auto and manual meaning that you will lock the clock. Free means without locking the clock system. So that is the meaning. And next, we have to set the clock synchronization mode of the base station, whether it's using FTD or TDD mode. So if FTD, it will be frequency, and TDD will be time. So let's look into the commands. So first, we were going to check the clock mode. So the clock mode is free because there is no reference clock. Next is the clock sync mode. And the clock sync mode over here, you can see that it is in frequency because this one is FTD clock. How about the TDD? So we're going to repeat the same command for TDD base station. For this, it will be frequency as well. So Q&A session. In eNodeB FTD plus TDD scenario, run the set clock sync mode to set the clock synchronization mode to time. Yes or no? Yes, this is true. So the summary of eNodeB device data, we have learned about basic concept of clock synchronization, synchronization requirements of LT base stations. We have learned on how to add an external clock, example GNSS, IP clock link, and synchronous Ethernet clock. And also, we also learned on how to set the system clock. That's all from me. Hope you enjoy the session. Thank you and bye.